Good afternoon, and welcome to the first Energy Storage Partner Program with Morningstar. And our guest and partner is Trojan Battery. This is the first time we've done one of these, and we're really excited about it. And I want to wish everybody a good morning or good afternoon, depending on where they are. My name's Mark. I'm with Morningstar, and you'll be hearing from two presenters today, Stacy Delzite from Trojan and Jay Sherry from Morningstar. So I'm going to turn it over to Stacy and let her introduce herself right now.
So my name is Stacy Delzite, and I'm from Trojan Battery. I'm a senior applications engineer here, and I've been with Trojan for about 12 years and have about another 5 years in the battery industry from, a prior company. So we're looking forward to this training and glad you guys are all taking time out, to learn some good information, we hope. Thanks.
Thanks, Stacy. And next, I'm going to just introduce Jay Sherry from Morningstar, tell you a little bit about himself, and then he'll be taking it away.
All right. Hello. Welcome, everyone. Glad to be here. Glad to have this opportunity to help, bring together two great partners, Trojan and Morningstar. I'll be holding up the end for Morningstar here. I'm an applications engineer, just like Stacy, and don't have quite as long a tenure as she does. I've been here for a little over 4 years, but certainly very proud to represent Morningstar. We have some great products and work together with many great partners in the industry, including Trojan. And so with that, we'll go ahead and give you a little bit of background on Morningstar for those of you unfamiliar with us. Basically, we have been in the industry since 1993. We are a manufacturer of solar charge controllers and inverters. Since that inception, we have sold about over 4 million units worldwide. So quite a lot of Morningstar product that has been circulated around the globe. One of the things that we pride ourselves the highest is that we have the lowest failure rate in the industry. Something that, again, is particularly important for our customers, being very critical of component reliability, minimizing system downtime, and so forth. So really, we are, without a doubt, the experts. We're the leading brand in solar charge controlling technology. Nobody else has focused on solar charge controllers for as long as we have. We have the most diversified product portfolio. Many of our products are application specific, so they really cater to every conceivable need, or so we hope. Many of the applications that we have, or again from this slide, just click through it here, give you a good overview. This basically shows you overall how many product lines Morningstar carries. We have over 8 lines of charge controllers containing 30 different models, again, catering to a number of specific applications. That's by far wider than anything you're going to find from a competing manufacturer, as you can see up here. And here we have just a nice snapshot of Morningstar's charge controllers that are capable of integrating with lithium batteries. All of these are custom programmable units, both in the PWM and the MPPT category. So you can see here we have the PWM and the MPPT. Let me see here. I'm not sure why the pointer is not showing. It's possible that it's on the other screen. Okay. Anyway, we'll go ahead and progress through here.
A little pretty, sir.
I don't know why that happened. Okay, sorry about that. A little technical difficulty.
Yeah, we're better at charge controllers than computers.
That's true. Okay, so really to segue in here, again, talk about the portion that Morningstar is responsible for, primarily being the charge controller component in an off-grid system. Right here, you see a DC coupled system that is referred to. What we are responsible for is converting the PV panel voltages to the proper battery output so that we can charge from solar panels or other renewable energy sources. The primary function there is to prevent overcharging, but also there are a lot of other additional functionality charge controllers can provide, including load management, which may or may not involve some degree of lighting control, turning loads on and off. And really, the main thing you want to emphasize with the charge controllers is that it's really the heart and the brains of the system. As you can see, it is directly responsible for the health of your battery. And so it's not a decision you want to take lightly. You want to make sure you make the right choice in that component, because if you make the wrong choice and you get a controller that is subpar, it'll be reflected in the lifespan of your batteries, which is a very costly expenditure. So with that said, charge controllers come in two flavors. We have, as I mentioned before, both MPPT, which stands for maximum power point tracking, and then we have the pulse width modulation charge controllers as well. They both have individual use cases and advantages for both types. MPPT controllers are primarily used in areas where you may have inconsistent sunshine or weather patterns where you may have some cloudy days or partial shading that may occur, some seasonal fluctuation, and especially in the cold weather climates, NPPT controllers tend to perform a lot better. They boost the output from the modules being able to operate at a higher voltage. And of course, one of the other advantages is that being able to step down from a higher voltage, if you can wire the array at a higher voltage, you can also accommodate, more simpler array configurations with longer series strings that can accommodate, long distance wire runs to reduce the effective voltage drop as well. All in all, you may be looking at up to 30% additional yield in optimal conditions with an MPPT compared to a PWM. However, with PWM controllers, they typically work well in areas where, again, the weather patterns are more consistent, not as much temperature fluctuation, plenty of abundant sunshine, and you can really, just install panels. You're not worried about, the array configuration, or, in terms of adding more parallel strings. There's no disadvantage to using PWM in those cases. And these are still very advanced controllers that feature actual continuous charging. They modulate the current output as opposed to just turning it on and off. So there's a lot of built-in intelligence and reliability that serves these controllers well in a variety of applications. So just to segue into the topic of this webinar and why we've invited Trojan to help join us here and host this. In Morningstar, we're starting to see some changes. Right now, not a day goes by we don't receive some type of inquiry about the use of lithium in remote solar applications. There's a lot of interest and desirability in some of the advantages it could potentially provide for the right customer and the right use case. Those including, again, an extended cycle life rating, maybe benefits of being able to operate at partial state of charge. That would all amount to fewer site visits, less maintenance. These are all great things for remote customers. One of the most common requests that our customers make when we distribute surveys to try to collect feedback is that they're looking for the manufacturer to really take the lead and provide a list of vetted settings for different battery manufacturers that they prefer to work with. And so this is really the reason we introduced the Energy Storage Partner Program. So now here, just to segue more into the Energy Storage Partner Program, we put this all together in an effort to, one, assure system designers that these components are compatible, they will interoperate to performance expectations. Two, make the system installation a lot easier, really plug and play. And for the end user, give them the peace of mind that this has been a well-documented and controlled system following a process with a lot of interaction between reputable manufacturers. That's what we've done. So with that said, I will go ahead and turn it over to Stacy. Stacy, if you're there, if you want to take controls away from me, and should be able to start back on slide 11. Yeah, she's just getting set up here.
We're just swapping things out. That should be right now, I believe. Thanks, Jake. I appreciate that. And we are going to talk about some of the energy storage solutions that Trojan has. Before jumping into the battery talk, I want to take just a brief moment to kind of introduce Trojan. We are part of C&D Battery now. Back in December, that happened, and we are, both long history in the battery industry, both companies. Trojan has been around since 1925. Mainly focusing on deep cycle applications. Golf cars is where we kind of are the most famous, I guess you'd say, and it's just kind of evolved from there. Basically we just make deep cycle batteries, and it's certainly a good fit for renewable energy. So that's why we're excited to be part of this program and part of this training today. C&D has been around since 1906. Their focus is mainly industrial power systems, things like UPS, telecom, utility switch gear. So there's not a lot of overlap, between Trojan and C&D's products or markets. So we're just excited about the partnership, because now what we have become is really one of North America's largest energy storage providers. So that's probably enough for the background on us. We ought to move right into the battery stuff now. And the first thing we're going to start with is our Trillium product. Very excited about this. This is our newest product offering. It is our lithium battery that we have. Since 1925, Trojan's been a lead acid battery company. Now we are lead acid and lithium. So we're definitely excited about that. Just the word Trillium is actually a play on words. It is Trojan Intelligent Lithium. That's what it means. The idea is that the battery has a battery management system, and it's going to give you plenty of peace of mind, plenty of runtime, and of course longer life than traditional lead acid batteries. The battery and the cell were both designed in the United States. The inside cells, the actual lithium-ion cells, are made in China, but they are to our specifications. We did not just go to China and buy an off-the-shelf cell. We designed it to our specs. They're actually Trojan maroon. If you were ever going to see the inside of a battery, the individual cells are Trojan maroon. So we're excited about it, and let me show you a few more some more details about the product. We have 3 sizes right now. We have 2 that are 12 volt. One is a group 24 size battery and 92 amp hours capacity. The other 12 volt is a group 27 size battery, and it's 111 amp hours. Then we also have a smaller, a U1 size battery. It's a 24 volt battery, and it's 22 amp hours. All of the batteries, as far as cycle life goes, they are rated at 5,000 cycles, and that is to an 80% depth of discharge when being discharged at the 1C rate. The 1C rate means if it's a 92 amp hour battery and you discharge it at 92 amps, that would be the 1C rate. So 5,000 cycles at 80% depth of discharge. As far as the intelligence that the batteries have, The Group 24 has the most features. It has a microprocessor-based battery management system, has a state of charge gauge, it does cell balancing, it tracks amp hours, and it also has a port which would allow for CAN communications if you have something, a data system to communicate with CAN, to take advantage of that CAN communication. The Group 27 also has the microprocessor-based BMS, and it has a state of charge gauge and does the cell balancing. And the U1 is the simplest. It doesn't have, some of the features of the other, but the applications that it's going into that, really shouldn't be a concern, but it does do the active cell balancing. So, Trojan is still primarily a lead-acid battery factory. So while we are very excited about having the lithium options, which will be a good fit, for some applications, we're also excited still about our lead-acid batteries. So we have 5 products that we consider our solar series batteries. And they pretty much run the range of capacity and voltage and whether you want to maintain them or they're maintenance free. So the options we have, just kind of starting on the left-hand side, we have our flooded industrial line batteries. These batteries are the highest capacity and they are rated for 17-year life. And then the next step would be our solar premium line products, which are also flooded, and they have an 8-year life. The next step, kind of, I say down, not really down, really just in budget and in capacity. We have our solar signature line products that are flooded and have a 5-year life. And then if flooded batteries aren't your thing, if you don't want to have to add water to batteries, we have a couple of options that are maintenance free. We have our solar AGM and our solar gel. Both of those are maintenance free. And the AGMs, there's an 8-year life on those. When I'm mentioning these life, when I say 17-year life or 8-year life, that is all based on some IEC testing that's been done. There's a test standard that's specific for batteries being used in solar applications, and IEC 61427. So that test, it's a pretty hard test that simulates the real world, for a solar application. So that's where those lifespans came from. So now we're going to move into why energy storage why the demand for energy storage is growing. There's no doubt that it's growing. We see it every day. And basically there's 2 main factors. We have falling cost. There's companies out there like Tesla and GE that are really doing a lot of investment in research and development and commercialization of energy storage systems. So that's helping things out a lot. And then also battery cost has decreased, especially when you look at the lithium-ion technologies. Those costs have come down dramatically over the last several years. And then the other side, we have falling costs, and then we also have rising market incentives. So we're starting to see a lot of regulation at the state and federal level that is favorable to clean energy. And then there's some incentives that we're seeing at state and local levels. And time of use management is becoming more popular. You could live in a market where it is less expensive to use energy at 4 in the morning than it is at 4 in the afternoon. So there are systems that can take advantage of that. So just a little more detail on how the energy storage market is growing. This is from cleanenergy.org. And basically what we're seeing is a 9 times, the market's going to grow by 9 times between 2017 and 2022. So, that's huge growth. You can see that here. And this is looking at residential, non-residential, and utility scale. It's what the data is looking at. And basically by 2019, so that's this year, we're supposed to have a gigawatt of deployment that this data is from a couple of years ago, so some of it's estimated, but we're getting to the point where we should have, nearly a gigawatt of annual deployment. And by 2021, so in just a couple of years, the estimate is that residential and non-residential, which is what we call behind the meter, that's going to make up half of the market by 2021. So definitely tremendous growth there. And then if we want to look at what batteries are being used, or what technology is being used to store, to make up the energy storage, we can break it down into lithium ion, lead acid, and then others. And you can see that, it's growing tremendously. Every segment is growing. And lead acid, there's still certainly a place for lead acid. Trojan's glad to have lithium as an option, but this data kind of shows there still is a place for lead acid as well. And mainly that's going to be off-grid. That's where we're going to see that mostly being used. And then with grid-tied systems, that's where we're seeing more and more use of the lithium-ion products. That just tends to be, what they prefer, especially with the price drop that's been going on. So now we're going to go into a couple of actual examples. Oh, sorry about that. The first one we're going to look at is railroad infrastructure. You may not think about it, but there's a lot to keeping the railroad running, right? There's a lot of maintenance there, and, keeping the equipment safe is important. We have to have reliable equipment out there so it's safe, and then also, moving the trains around efficiently. So there's a system called PTC, Positive Train Control, basically that collects data, and it helps keep the whole train network in the United States safer. And that data, they collect more and more data now because they can. Wireless networks have grown, and data cost is not as expensive as it used to be. And then there's some government mandates too. But all of this tends to be, off the grid just because of the location. So of course they need batteries to supply the power for those. So in this case, lithium is a really good choice. Lithium, it'll fit in their new systems, and if they're retrofitting a system, they can put a lithium battery in there. And, even though they do cost more initially, they provide such long life that their value proposition, makes sense in these applications. They also have very, very long cycle life with no maintenance. So that, that's a huge advantage, because you're not having to send people out to these, remote sites and maintain batteries. And then there's built-in, the controllers of lithium batteries can also be integrated into systems that are to the data systems that are already at these locations. So that makes them handy. And then just continuing down the list as, why they would choose a lithium battery. Partial state of charge. Lithium batteries are pretty happy at partial state of charge. That's really not the case with lead acid. So, partial state of charge makes them great. And, it may not be sunny all the time, and they'll still perform, without adverse effects. And a lot of the regions where the railroad exists, there's really not temperature extremes there. Because one of the things that we'll talk about in a little bit, charging lithium batteries when it's very cold is an issue that has to be addressed. Well, with this railroad case study, that really is not in play, because there's really no temperature extremes. And then also lithium batteries have really high charge acceptance. Whatever energy you can give to them, they'll take it. So that means that, they're charged faster, and they're able to store that, during the small charging window. So moving on to another application, we're actually going to talk about the oil and gas industry. And this one, what they do in oil and gas, again, these are remote locations, and they're quite often off grid, and there's a lot of data being collected. These systems have been in place for years, and they're collecting data, But the thing is, they're always automating and making the systems, more modern and increasing the amount of automation. And so that means they end up using more power, and they're still out and they're off grid, so that, they need more storage. So as far as the type of things they use the energy for, they have data measurement. They use some to actually move some valves, chemical injection, cathodic protection. That's basically corrosion control, because they've got all kinds of metal pipes and stuff out there. So that's why they need batteries. And in this case, AGM is actually a good choice. Tried and true. I mean, AGM batteries have been around since, the 70s, but it's a really good fit for this application. One of the reasons is because of the temperature extremes that they see. There's oil and gas fields in Canada, and there's oil and gas fields in South Texas. So because of that, there's this wide range of temperatures, and AGM batteries can handle that. And then the batteries are sized to allow for a shallow discharge, so that gives them several days of autonomy in case, either because it's cold and they need that extra autonomy, or if they're not getting recharged because of cloudy conditions, they benefit from the autonomy. The other thing that's easy with AGM batteries is connecting them in series and parallel. You can mount them in any position because they're considered non-spillable, and also because it is just a very simple, chemical. The way the batteries are built, it's just a simple chemical structure. We put spark arresters in there. There's no internal electronics at all, like you'd find with a lithium-ion battery. And because of those features, that means you can use the batteries in areas that are classified as Class 1 Div 2, which is a kind of a safety requirement that some wells require. So we've talked about, a couple of real-world situations where we were, looking at AGM and lithium batteries being used. But what are some things that we need to consider before you just drop a lithium battery in? It's not just as simple as, you can't, if you've been using a lead-acid battery, it doesn't mean you can just put a lithium battery in there. There's some things you need to look at to consider. The first is the battery management system. Lithium batteries require battery management, and if the battery doesn't have it, and in most cases the batteries will have it, but if the battery doesn't have a BMS, then you're going to have one in your system. Another consideration is the narrow voltage range. What that means is there's not nearly as much difference in the voltage between a fully charged lithium battery and a fully discharged lithium battery compared to lead acid. With lead acid, we've got 4 or 5 volts to play with there. With lithium, you've only got, maybe 3/4 of a volt. I mean, it's less than a volt between basically full and empty. So because of that, that means you can't just take a voltage reading and know what the state of charge is. You have to have more sophisticated data monitoring. Something like amp hour counting is fairly common to know the battery's state of charge. Cold temperature charging, and this is a big deal. You can damage a lithium-ion battery if you charge it when it's too cold. And this is permanent damage. It's, irreversible damage. So to make sure that you're going to keep the battery in good condition, you need to have a charging system that can throttle back the current when it gets really cold. So that's a big deal, and it's something that has to be managed somehow. So definitely a huge consideration. Also, fully discharging the batteries. A lithium battery, if you fully discharge it, and especially if you let it stay fully discharged for any amount of time, we call it chemical death. I mean, the battery just will not recover. And because of the difference in the voltage range, sometimes your low voltage disconnect point is not properly calibrated with the state of charge of the batteries. So you can fully discharge the battery and not realize it. So big consideration there as well. Another thing about lithium batteries is they have a very, very low rate of self-discharge. So that means just sitting on the shelf, they're not losing much state of charge. And that makes them really good for systems that aren't frequently used. You know, if you might have a remote cabin or, you know, something that you're not going to visit very often, it's good in those situations. Another point is that lithiums have a very high charge and discharge rate. That means that the batteries can provide a lot of energy if they need to, and they can also accept a lot of current. So that's good, because especially with renewable solar situations, you know, it's not always sunny 8 hours a day. So, you know, you may have a very small window. So you can really benefit, you know, if you've got an inverter charger system that can really get that current into them, the batteries will benefit. The last point is lithium batteries definitely have a higher upfront cost, but they also have a longer cycle life, right? So to really understand whether or not it makes sense financially, a customer has to kind of have a good grasp of his system, you know, because they may just look at it and say, well, these things are too expensive. I can't afford this. But then, you know, once you look into it and you say, yeah, but they're going to last this much longer, you know, the costs per year come down, or the overall costs come down. So now we're going to move into some things that are specific to Trojan's Trillium products. I mentioned that, you know, well, I don't know if I said it, but our lithium batteries have been on the market since last fall, not quite a year yet. And, you know, when we were doing the development of the product, one of our biggest concerns was safety. So there's several different lithium ion technologies out there, and they're not all equal. So we ended up choosing the lithium iron phosphate, and safety was a big reason for that. It is definitely one of the safest chemistries. And I mean, that's why we chose it. It also, you know, there's a good balance of, you know, with energy and lifetime and cost as well. Another feature on our Group 24 and Group 27 batteries, we have a state of charge gauge. And this gauge, I mean, it's very helpful because, like I've mentioned, voltage can be misleading with lithium batteries. So this gauge is there, and it's actually counting amp hours. That's what it does, the battery management system. It's part of the BMS, and it's counting amp hours. So to find out the battery's state of charge, you simply press the status button there, and then you will get an indication in the indicator area where, you know, you'll either get solid green, blinking yellow, you know, just based on the scale here. And in fact, lithium batteries have to ship at about a 30% state of charge. That is a DOT regulation. So it's normal when you get the batteries, if you press the status button, it's going to be kind of in this blinking yellow range. That's going to be that 30%. So the first thing you're going to have to do is charge the batteries. And charging them, we recommend that you use an AGM or gel charging algorithm. If you have a lead acid charger that, you know, that has different charge algorithms in it, those algorithms, it's usually a constant current, constant voltage type algorithm, and they do not get to really high voltages at the end of charge like flooded lead acid batteries would. But the very first time you charge the Trillium batteries, they have to be balanced. There's, you know, 100 cells inside there connected in series and parallel, and those 100 cells have to be balanced with each other for them the very first time they're charged. And what may happen is that as that balancing is happening, the voltage is going to get higher than the battery management system will allow. So it will actually open a contactor in the battery, which stops the charging. until the voltage drops. And then, so that's going to go on for several hours the first time you charge the batteries. That's normal. It's to be expected. We've got batteries, in the field now, and we get calls about it all the time because it's confusing to people because, this battery can turn itself on and off, and, your regular lead acid battery couldn't do that. So it's normal. It's to be expected. But then once the batteries are balanced, you don't have that happening again. So on these graphs, we're kind of showing this on-off behavior on the top one, and it takes 4 or 5 hours for them to balance out. But then on this next charge cycle, that doesn't happen. And they just charge for an hour at the end, and they're done. So, of course, one of the biggest advantages with lithium batteries is how long they last. They definitely, typically they're going to last longer than a lead acid battery. This is the cycle life data that we have. Over here on the left, we're showing, at various depths of discharge, actual cycle life testing. And then on the right, this is the cycle life that you can expect from the battery. So this is at the 1C rate. So the 92 amp hour battery, we're discharging at 92 amps down to 80% depth of discharge. And we see more than 5,000 cycles. So very, very good long cycle life there. Now, going back to lead acid for a little bit, because like I said, there's still a place for lead acid batteries. Looking at the cycle life for our different solar products, you see we kind of have a range, right? Some of our smaller solar signature batteries at a 50% depth of discharge, we expect 600 cycles. And with our solar industrial batteries, 50%, we're all the way up to 3,700 cycles. So, whatever need is there, we have a wide range there. But of course, in order to get this cycle life that's expected, you need to charge these batteries properly as well. And this is our flooded profile, the charge profile that we recommend for flooded batteries. The voltages and the parameters are here. But basically, we want you to absorb the batteries at about 2.45 volts per cell, and then equalize up at 2.7 volts per cell. And, that's kind of what we like to see with our flooded batteries. Now, with our AGM and gel batteries, you don't absorb quite as high. We like 2.4 volts per cell. And then you're not going to equalize those batteries at all. Equalizing valve-regulated batteries, an AGM or a gel, is going to cause them to gas and to dry out, and which is going to cause them to fail. So we definitely don't want to do that at all. So we've talked a lot about different battery options, how you take care of them. But a big part of an energy storage system is knowing how many batteries you need, right? We have a tool that will help you for that, to help you figure out how many batteries you need. Let's see if I can get this to work. I'm going to have to jump over here. So this is batterysizingcalculator.com. That's, the website. And basically, it's a fairly straightforward system. In the first step here, you have to put in a few basic parameters. What's my system voltage? Is it on grid? Is it off grid? What's my daily depth of discharge? What type of battery do I want? And how many days of autonomy? So that part's fairly straightforward and easy. It's the next part that's trickier, right? Because nobody knows what they're going to run or how long they're going to run it, and So this is just a very simple example. I just put in a refrigerator. We're going to run it. We have one refrigerator. It's going to run for 8 hours a day. They run 24 hours a day, but they don't actually cycle on 24 hours a day. So, and of course that varies based on how much food you have in your refrigerator, how hot your house is, those kind of things. But this is a decent, this is basically running a third of the time. And then how many watts the refrigerator requires. And if you don't know that number, it should be on your appliances, but then there's you can click here to see average wattage for typical appliances. That takes you out to an energy.gov kind of website, to give you just typical numbers. So then I put in just a few LED lights. We got 10 of them. We're going to run them 6 hours a day, and they're 8 watts each. So then you come up here and you can kind of see what it's telling you. The system accounts for 15% inverter loss, especially if you're going from DC to AC. And then there's also a little bit of efficiency loss due to the wiring. So the system accounts for some of that, and then it ends up telling you that you need a 230 amp hour battery bank. And then down here at the bottom, it offers suggestions. So, we have a gel, we have a solar signature, we have a Trillium, we have, one of the giant industrial line batteries. So basically, it's going to tell you how many batteries you need, the calculated depth of discharge, and then based on the depth of discharge, it's going to give you an estimated cycle life. Once you have this information, you can start making decisions. So just a real quick, we'll look at this. Solar AGM battery. So this will be a maintenance-free battery, and you'd get about 2,300 cycles from them. If you went with the Trillium battery, you'd get 9,600 cycles from them. So, at that point, you can start doing math. I'm going to cycle them daily or every other day, and you can figure out, your cost, basically. This information can be exported. You can send it to a PDF or you can print it. And then you can also, you can just start playing around with this. You can remove line items, you can add line items, but it's a really handy tool, and it's proven to be pretty helpful. And we're glad to help too. It says right here, you can contact us here in tech support if you have questions about it. We're glad to help you. So that's really, I'm pretty much finished with my part, and I'm going to turn it back over to Jake if he's ready to take the controls back.
Yep, I'm ready. Let me see here. Pass it back over. Show my screen. Should be showing me now, right? Mm-hmm. All right. Thanks a lot, Stacy. That was a good overview. And now that you've heard kind of both sides, the batteries and the charge controllers, let's show you how they work together. Just to circle back to Morningstar and what we can enable through our product design to accommodate any battery, whether it's lead acid, flooded, AGM gel, or lithium. We have a number of features that cater to the specific needs of that particular battery. Again, this is a rundown of about 5 features here that are more pertinent to the lithium specific features, where one in particular is called lithium foldback or low temperature foldback. We'll talk about that on the next slide and show you how it works, but basically it allows you to specify a temperature D rate, a current D rate that coordinates with low temperature decreases, so that it doesn't harm the battery, much like the charge controller will automatically do at high temperatures to prevent damage to the controller itself. We also have an interactive meter display option on several of our controllers. This can be used to tailor the main settings, absorption, float, even load disconnect settings. You can do that straight on the meter display, no connection to a PC required if you just need to make slight adjustments. There's a feature of some of our controllers that use a remote temperature sensor. You can basically use that as almost to replicate a pair of on-off terminals, so that certain batteries, their battery management system may have a signal output for an alarm function. Maybe it can be like an early warning type notification that can then be relayed to our controller through the RTS terminals to disable charging to prevent further damage to the battery. That would be one useful feature. Also, the controllers are programmable via USB. All you need is a simple cable adapter to connect the controller to the USB interface on your PC. You can use our MSView software, which I'll talk about coming up, and basically just import file downloads from our website and load them into the program, and off you go. And then lastly, there's a voltage sense feature, which is particularly helpful for enabling accurate battery charging, making sure you're getting the most accurate voltage readings on the controller, which again makes all the decisions based off of those measurements more accurate as well. Go on from there. Yeah. 1 second, sorry. There we go. All right, so this is an illustration of that low temperature fold back feature that is particularly useful for lithium battery charging. Again, Stacy mentioned earlier in the presentation the sensitivity to cold temperatures, just something you want to be aware of. And of course, we try to accommodate that with additional feature capabilities. This chart here is specific to our ProStar MPPT, and this was published by a particular battery manufacturer where they have settings outlined for a range of temperatures, and they can specify a derate curve so that again you can start to dial back the current as the temperature gets colder and colder to prevent exceeding that cold temperature limit where you risk damaging the chemistry in the battery. What we have done is we have a low temperature setting where we can specify both a high and a low temperature threshold, and then the charge controller will just linearly derate the current between those two thresholds, to approximate this curve and still allow it to charge, but without causing damage below a certain point. So that's also a particularly useful feature that you'll find on our some of our controllers. Okay, and there's also a number of other advanced custom settings for again special applications that you may want to be aware of. High voltage disconnect, there's really two forms of high voltage disconnect, that for the battery and that for the load. This one pertains to the load. So again, certain loads are sensitive to high voltages. Maybe it's an oil and gas piece of equipment where you don't want to exceed 15 volts per 12 volt nominal. You can specify that high voltage disconnect threshold so that you don't risk damaging the load. You can also specify a max regulation voltage, which would basically allow the load. If it's a load controller, it has an integrated load circuit, it basically just feeds off the battery voltage. So you can specify a max regulation voltage so that the battery is not charged above a certain threshold, and that voltage is just maintained, just enough to not cause an overvoltage condition, on the load. Also, you would have potentially a need for absorption extension. This is mainly useful for lead acid batteries where, if they're cycled deeply the previous day, the charge controller has some added intelligence to extend the absorption interval the following day to try to recover some of that lost capacity. And then also just the ability to tailor the temperature compensation variations, which again may be specific to a particular battery chemistry. Lithium doesn't need any temperature compensation. Nickel cadmiums may have different temperature coefficient requirements than conventional lead acid batteries. So you want to be able to adjust not only the temperature coefficient, but maybe the temperature windows that you intend to enable temperature compensation. So that just gives you an idea of some of the capabilities of our controller. And again, when it comes to lithium specifically, There's really two different forms of integration. You can do it open loop or closed loop. Everything we're talking about here is open loop control. So basically through collaboration with Trojan, working directly with them, we have extracted the appropriate settings, we've tested them in-house, and we've been able to vet the appropriate settings given our custom charge algorithm where we can fill out the table accordingly. We've considered things, again, the standard requirements for any lithium is to disable temperature compensation. We're able to do that. Disable equalization. We have that low temperature fold back, which is a nice additional feature to have in your back pocket. Again, if you're approaching those cold temperature environments and you still want to use lithium, you can reliably, prevent damage to the batteries in those conditions, not have to worry about it. Absorption time and transition to float are important things that you want to get right as well, because with absorption time, it's not like lead acid where you need really long absorption times to make sure the battery gets fully charged. The lithium batteries can handle partial state of charge, and you don't want to dump large amounts of current in when the battery management system is performing balancing of the individual cells. Otherwise, it could potentially trigger an over voltage condition and an internal disconnect. So you want to be mindful of the absorption time. And of course, the LVD and HVD control for the battery. These are all things that are very important to consider when outlining a charging profile for a lithium-ion battery in a open loop operation. Of course, we've thought about all that for you, so you don't have to. Some other things you might just want to consider, again, I think Stacy mentioned earlier, the convenience on the G24 and the G27 batteries from Trillium. They have the built-in state of charge gauge, which is very nice, again, allowing you to see more clearly what the state of charge is instantaneously in the battery, as opposed to relying on voltage measurements, which are not very accurate for lithium batteries. It may also be recommended that you incorporate an external shunt monitor to provide some of that data, especially if you need to access it remotely. There are several third-party options available, so feel free to contact either us or Trojan for recommendations on those products. So with that said, I just want to show you really how easy it is. We've done all this work in terms of outlining the settings, working directly with the battery manufacturers like Trojan. So what we've enabled through the Energy Storage Partner Program is very simple to see. If you go to our website, you either go directly to the link you see there, Energy Storage Partner Program, or you can go under the Resources tab. You'll find it there as well from our homepage. You'll scroll to the bottom of the Energy Storage Partners page, and you'll see a information request form. You go ahead and just select the battery brand you're interested in. In this case, we see Trojan, and you go ahead and submit the form, and then you'll get access to the downloadable PDF containing all of the information relative to the settings, battery overview, and then any additional accessories or hardware that are needed for successful installation. Within that, there is also a link to the zip file containing all the MSU setup wizard configuration files. And so if you just click on that link, that will initiate the download. And you'll see here in the following slides, you just click on the extract button there at the top of the page to unzip. You extract the contents, and it'll ask you for your destination. Go ahead and click extract. Meanwhile, if you don't have it already, you're going to want to download MSU. You can find that under the products tab on our webpage. You scroll down to MS View and click on that. You'll come to the MS View homepage with a little short description, a click here hyperlink. You go ahead and click that to initiate the MS View download. And then once the application software has been downloaded, you go ahead and launch the executable file. You'll see this window pop up. You go ahead and click on the Devices tab in the upper left, and you select the first one, just search for connected devices. Of course, you'll want to connect your device via serial communication if you're using a USB adapter. Go ahead and connect that to your USB COM port on your PC prior to that. When you search for connected devices, it should automatically recognize any connected devices. Go ahead and select the one you want and click Connect. And then once you've actually established connection to the device, the icon there should turn green, show you the item, the model number, and the 8 digits following it are the serial number. So that's conveniently located there. And then what you can do is you can go ahead and enter the setup wizard for that particular controller. So in this case, it's a TriStar MPPT. Go ahead and select the TriStar MPPT setup wizard. And you just select the, you get this custom set points summary window that pops up. Go ahead and click the read from file. Then you'll go ahead and find the earlier configuration files that you downloaded, and make sure you go ahead and select. It should automatically recognize the file by controller type, depending on what setup wizard you're in. So again, we're in the TriStar MPPT setup wizard. So it automatically selects the .ts MPPT file type. You go ahead and click Open. And then you're in, you've uploaded the settings to the, uploaded the settings to the setup wizard. You haven't quite pushed them to the controller yet. If there are any additional modifications that you want to meet, you want to modify, feel free to do that at this point. Prior to programming the controller, you can scroll through and actually edit the setup wizard. If there's any application specific things you want to add to it, maybe some lighting control with some on-off load timing or something like that. And then once you're through the setup wizard, again, here you'll see within the setup wizard, this is one of the first pages of the setup wizard, you'll find that low temperature fold back. If you're using like the ProStar or ProStar MPPT controllers, that's where you would want to input that data. And then you just click Next all the way through to the finish of the setup wizard. You'll come back to this window with all the settings populated. And then you go ahead and lastly just click the Program TS MPPT button. And it will take you through to guide you with on-screen prompts to power cycle the controller in order for the new settings to take place. And then you should be off and running with your new system ready to go. I think that pretty much shows you how easy it is to take the information we've compiled through the Energy Storage Partner Program and use that, very plug and play. Of course, if you have any questions, we're happy to answer them for you. So with that said, I think we'll go ahead and go to our summary slide here.
And we'll just take questions after this. We covered a lot of ground, so let us know now what you'd like to know. Any questions that we can answer for you. And thanks very much for attending.
Let me pop open the questions here.
Oh, we got a bunch.
Yep. All right.
Somebody's asking us if in the telecommunications industry, there's a sort of trend for implementing lithium-ion batteries more than in the past. How comparable is the increase of lifespan with the increase of price related to lead-acid batteries? That's a really good question.
We want to pose that one to Stacy.
Yeah.
Stacey, did you catch that? You
Well,
want us to read it
I
again?
did. No, I've got it. I can see it here on the screen. We're not really in the telecom industry. That's the problem. I mean, we are newly now with C&D, but I don't know very much about that application at all. I don't know. That might be one that we need to follow up later. Can we do that? Is there an option where we can, in case we have other questions?
Sure, yeah.
Okay.
Yeah, absolutely.
I think the gist of the question was really more how comparable is the increase in lifespan in relation to the increase of price relative to lead acid? If the battery is going to last a lot longer, but the price is higher, how does that pencil out with the comparison to lead acid batteries?
Well, the thing is, there are batteries in there's lead acid batteries in the telecom industry now that can last 15 to 20 years. And it's not the batteries that Trojan makes. I mean, but there are some very, very long-lasting lead acid batteries already in use.
Right. Yeah, that's a good point. Yeah, we may need to follow up just with a little bit more specifics to address that question, but we're happy to do so after the webinar.
Sure. Another one that is directly asked of Trojan is, how have you overcome some of the inherent instabilities of lithium battery BMS systems when you have, say, 4 Trillium batteries connected in parallel to a 48-volt system?
Yeah, I think in series they mean, but
yeah, I think that's what they mean.
Yeah. I guess, Stacey, are there concerns in terms of stacking the like 12-volt batteries if you had 4 of those in series for a 48-volt with each, independently regulated BMSs? Does that cause any conflicts in the system? Is there anything that Trojan has done specifically to address some of those concerns? Stacey, are you still there? I may have lost her. Okay. All right. We won't go through that one. I'm sorry.
We didn't get one on any special charges required for balancing lithium, or is it just a matter of procedure, low voltage, etc.?
Oh, for which? I'm sorry. This one. Okay. Is there a special charger required for balance lithium? Yeah. So that's a good question. It's mostly, again, any charge controller that is custom programmable, which is, the ones that we highlighted on one of the earlier slides. Many of the settings are consistent from one product to another. The key settings are the regulation voltages, your, low voltage disconnect, your high voltage disconnect settings. Sorry, Stacey, are you there? Oh, no, sorry, I thought I might have heard. Okay, the low voltage disconnect settings and so forth. All of that again is custom programmable for any of the controllers that I mentioned. So they would all be compatible. No one is necessarily more suitable for lithium than the other.
This is a good question. How comparable is derating due to low temperature with lithium ion?
How comparable derating due to low temperature? So I'm not sure I understand the question. How do you interpret that? How is comparable derating due to low temperature?
I think what he's asking is the lithium batteries derate as the temperature gets lower, but maybe what he's really getting at is low temperature fallback.
Yeah, that's my guess is that is what is he's getting at. I think the thing to remember with lithium, again, most of the batteries don't recommend discharging below minus 20 degrees C. Some and most don't allow charging below 0 degrees C. So no charging below freezing temperatures. That's definitely something you want to consider, and seems to be fairly consistent across the board from one manufacturer to the other. some battery manufacturers may have other ways of dealing with that, but the low temperature foldback provision that we incorporate into our controllers is definitely a useful way to deal with that, to ensure all of the charging current is cut off, below a certain threshold, so you don't risk damaging the battery.
We got a lot of good questions just going down. You want to pick up another one, Shake?
Let's see here. There's a lot of
Most
them.
recommended Morningstar charge controller for a lithium-ion Trojan battery.
Yeah, it really varies again based on your your supported voltages, your battery size and load requirements. It's really the battery itself is almost agnostic to which charge controller you use with it. It's just more choosing the right charge controller for the application, I would say, is probably a more appropriate.
But also, we do have 6 lines that are perfectly compatible with lithium. That would be the TriStar MPPT 600 volt, the TriStar MPPT, TriStar ProStar MPPT, ProStar, and the SunSafer MPPT all have lithium features on them. So
correct.
Quite a few.
Yeah, those would be the main ones to choose from. However, they do cover a large range of power and voltage requirements, so it's very specific to your application.
Please make the slides available to us. We will. Everybody will be able to get them after the presentation, so that'll help. And let's see, we'll take one more. Anything there?
Should we give this?
Whatever you.
Let me see here. See a good one for Stacy.
I think I'm back. I think I'm back.
Oh, good. Good.
I thought I heard you in the background. Okay, let me see. What should we do?
Yeah, that
we
one
did that.
actually. Regarding the Stacy, regarding to the Trillium line, someone would like to know if they can increase the voltage to 48 volts using 412 volt units.
Yes, there's no problem. You can connect 4 in series to make a 48 volt system, but that is the maximum voltage of our existing BMS. And that may change one day, but our existing BMS has a 48 volt limit.
Right. And here's an excellent question that came in later in the. I realize we've gone over too, so apologize for that. But it's a great topic, and we have a lot of people asking questions. Someone in the audience would like to know how unique are the charging profiles from, say, one manufacturer to the other, and could they safely use the voltages on our chart for any flooded batteries from any manufacturer? I think that's directly aimed at one for Trojan, Stacy.
Yeah, that's fine. I mean, we would recommend that you check with the manufacturer of the product. I mean, for the most part, they are pretty similar, but some batteries, especially batteries that last a really long time, they may operate at a lower specific gravity and have slightly lower charge voltages. So it's always best to try to get those specific manufacturer recommendations. And then otherwise, you can just go with one that at least matches the technology, like AGM or flooded or gel.
Right. Great. We have one very specific to Morningstar, but it's on one of my favorite topics, so I want to answer it anyway. And someone would like to know if our EcoBoost MPPT charge controller can be programmed through its USB port, or is that only used for charging phones and tablets?
So that's a good question. The 2 USB Type A ports that are on the EcoBoost are just for phone charging. They are not data ports. So if you are programming the EcoBoost, you'd have to do so via the model with the built-in meter display. And then you would have to, again, scroll through some of the basic settings, your set point voltages for absorption float, equalize, your LVD, LVR settings, and so forth. are still available for custom programming to the meter display.
Great. We'll take two more on the lithium batteries in particular. First one's an excellent question about internal safety features. Somebody in the audience mentioned that they didn't notice any breakers on the Trillium series, but what physical safety measures are in place to protect these batteries from extreme heat, cell balance issues, or any internal shorting?
Gotcha.
Sounds like one for you, Stacy.
Yeah, okay, sure. There's a couple things. I mean, the battery management system itself, is designed to protect in an over voltage situation, an under voltage situation, high charge current, high discharge current, temperature, if it gets too hot or if it gets too cold. And there's actually a contactor in the battery that the battery management system will open. And when that contactor opens, you're effectively turning the battery off at that point. And then secondary to that, there is a fuse. But that's just redundant safety. If something crazy were to happen and the battery management system failed, there is a fuse for utmost safety.
Great. And then the final question that I think is a really good one. Now, granted that given the longer lifespan of lithium batteries, that's a can you can kick down the road for a long time, but eventually you will come to the end of the road. Someone wants to know, what are the complexities for disposing or recycling lithium batteries in renewable energy systems, say, versus flooded batteries?
You want me to take that one?
Yeah, I think that would be great.
Okay. Lithium batteries can be recycled, but the thing is, there's a cost associated with that recycling at this point. We've actually partnered with somebody up in Michigan. I think they're called Energy Storage. And so you can send batteries there for them to get recycled, but it's not like lead acid. At the end of life, lead acid, there is some value still. You turn in those batteries and you get a poor credit. With lithium at this point, there is still a cost associated with recycling, but who knows? That may change as there's more and more batteries being recycled. When we get to that point, we're just not really there with a lot of big lithium batteries yet.
Great answer, thanks. And I think the lesson there is just that that's something that one wants to build in when one costs out a lithium system, and just anticipates that up front, knowing that that may be included. So I think with that, we'll sign off. We'll make the presentation available shortly after the call. And we want to thank everybody who stayed through this. We ran into overtime here, but it was a great topic, and I think everybody got a lot out of it. So thanks again for attending, and we'll see you on the next one.
Thanks, everyone. Thanks, Stacy.
Yeah, thanks, you guys. We enjoyed it, and glad everybody could participate.
All right. See you next time.
Okay, bye-bye.
Yeah.